Hi again, and welcome to Lesson 2C. In Lesson 2C, we're going to have a look at the most common dimensioning error. Then we're going to take our drawing and we're going to turn it into a three-dimensional object for the first time. Now, I'd like you to get Smart Dimensioning again, and I'd like you to put a dimension on the vertical side opposite to the one that you've already dimensioned. So we'll click over there, we'll take it off the drawing a little bit, and we'll put it in the center, and we'll click it. And we have an error message on our hand. We've got a pop-up box and it says, make dimension driven. The high voice was for the question mark. Adding this dimension will make the sketch overdefined or unable to solve. Do you want to add it as a driven dimension instead? So let's think back a little bit about what a driving dimension is. The driving dimension is an editable dimension that forces the line to change to the size that you edit it to. And overdefined would kind of mean that something's getting two instructions at once that might be in conflict with each other. So what's the problem we have here? Why can't we edit the dimension on the right-hand side? In my case, I did the left-hand side first. So why do you think we can't dimension that right-hand side, or at least change the dimension on the right-hand side without causing a problem? What shape do we have here? Yes, it's a rectangle. And what is the orientation of the top line of the rectangle? You can see the little yellow box there. Horizontal. Bottom line. Horizontal. Left vertical is a vertical line, and the right one is a vertical line. So what we have here is something that has parallel sides on the opposite sides of it. Where if we look in the corners, we don't see any indication of 90 degrees. It just happens to be 90 degrees because these parallel lines are vertical parallels and horizontal parallels. The reality is what we have here is a parallelogram. And the property of a parallelogram is that the opposite sides of a parallelogram have to be parallel and equal in length. As long as this thing's a parallelogram, we can't put two editable dimensions on opposite sides because the one side's dimension forces the other side to have to be the same. Let's see what we can do. Say we really want to change that dimension. So we'll cancel out of that error. And we're going to press escape, and escape is the bye-bye key, the backup key in CAD. I make a lot of mistakes, tend to hover my hand over the escape key and push it pretty much endlessly. I think it's pretty much worn out. Now, we're not dimensioning, we've just got the drawing. I'm going to select the top line of the drawing, and I can see I get a little green square with my horizontal on it, and over on the left, I get a line properties box. In that line properties box, if I go down, I'm going to see existing relations, horizontal 3. Related to the origin, related to the planes, this is horizontal. So I'm going to right click on that and I'm going to press delete. And now my little green box went away. So I'll say yes. I'm going to press escape to deselect that line. Otherwise, when I select my smart dimension, because it's already selected, the dimension will be immediately applied to that horizontal line, which is not what we want. Once it's deselected, I'll go over and get smart dimension. I'll come back to my right side vertical and I'll put in my dimension, put it in the middle there nicely and click. And 60 millimeters, I'm going to say yes. And lo and behold, no error message. Let's double check this thing. So we'll escape to get out of dimension tool. And I'm going to double click on that 60 and I'm going to change that to 70. And yes, it allowed it to go in. My top line is no longer horizontal. It's now on an angle. But if you take a good look, you can see that the 80 millimeter dimension went with the line, which means that our bottom line is no longer 80. So we're going to take a little break from the CAD here, and we're going to go over and we're going to see if we can calculate the equation for what the length of that line will be. First step to doing that is to look at that top line and see that it becomes kind of like a spoke on a wheel, pivoting around that point at the top of the left-hand vertical. And in doing so, because the other line on the other side of it, the one that's labeled as 70 right now, it has to be attached to that line. The 80 millimeter line, depending on what angle it is, now sets the horizontal distance between the two vertical lines, which happens to also be equal to the length of the bottom line. Can we think of a mathematical relation that equates circular motion to linear distances? Furthermore, if we take that line, that 80 millimeter line, and we make it horizontal, is that going to be the maximum distance that those two verticals are ever going to be apart? And if so, what's the maximum number that we'd ever have to multiply the length of the top line by to get the length of the bottom line? And of course, if they're equal, the number is 1. So we've got a relation that goes between 0 and 1 or -1 and 0, and relates a circular motion, a radial motion, to a length. We should remember that that means that we're dealing with the sinusoidal types of motions, sine, cosine, and tangent. So now we can take that top line and we'll leave it at our nice angle of 70, 80, 60. And if we draw a horizontal from the top of the 60 millimeter line across till it meets the 70 millimeter line, it's going to be parallel to the bottom line, which means we're back to our parallelogram. So it also means it'll be the same length, but it's going to meet the 70 millimeter line at 90 degrees. So we've got a 90-degree triangle that has a hypotenuse of 80, an unknown base, and then a height of 70 minus 60. So we think about our old cliches of SOHCAHTOA, and we can use those. So we don't know what the angle is, but we do know that sine is opposite over hypotenuse, and our opposite, if we put the angle where the 60 meets the 80, if we put that angle in that corner, then 70 minus 60 is our opposite, which is 10. So sine equals 10 over 80 equals 0.125. So we now know theta. We now know the angle. We can then turn around, plug that into the cos equation, and cos is adjacent over hypotenuse. And we can go cos theta h equals adjacent, which is the unknown, the one that we want. So the length of that bottom line is going to be cos theta times the hypotenuse. This is not strictly speaking needed for this particular lesson that we're trying to teach you here, but it will come back into play later on when we start talking about resolution and how the CAD actually displays things. Keep that in mind, because think of kind of what a pain in the backside that math is, because there's going to be operations that we're going to do later on that's going to make the CAD have to do a lot of that. So now this is the part where we teach you the very important lesson of lazy is good. So there's a hard way to get back out of this thing, and there's an easy way. Because they both get us to the same destination, the lazy way is the good way. So we're going to press Control Z, and we're going to keep doing it until we see that horizontal relation come back in. Once we've got it, we're good. We have a rectangle once again. We've now covered the 5 most common errors you're going to run into in this CAD. There was the 4 that caused the shapes not to turn into 3-dimensional objects. And then the 5th one is where you add a dimension that, because of some other property, if you edit it, would cause something that is true to be untrue. So it can be fighting with another dimension, or it can be fighting with a midpoint. So if you take a line and you dimension from one end to the midpoint, and then you try to dimension from one end to the other end, you're going to get this same error because you've got 2 editable dimensions that you can't change them independently because they're locked together by a property, that property being the bisecting length of that line. The point is, if you get an error that tells you that you're overdefined, you need to go look and see what would have to become untrue for you to edit that dimension. And then you can either delete the dimension if you didn't want to change the other thing, or you can delete whatever property is that's locking that other thing into the shape or size that you don't want it to be in. And you can go into the properties of that, delete it, and allow that to freely move. We've got our rectangle, and we can exit sketch. Now we're exiting sketch, and you can see that we've popped back over to that first view, that dimetric view, the angled view, because if we look at a 3D object from right above, it's hard to see what's going on. If you think of flying over Toronto at 40,000 feet and looking straight down on all the tall buildings, other than the CN Tower, that's cheating because it's round and it's easy to know, but all the rectangular buildings are just going to look like rectangles if you're straight up over Toronto. But if you're coming in on Porter and you're flying into the island airport, you look over and you're looking at an angle, it's very easy to see which ones are the tallest, widest, thickest, because you're looking at an angle where you can see all those different aspects of it. So the CAD tells you, well, when you're in 3D, this is a good angle to look at it at. But I like to call this the first date, because we all know those guys who are super charming on the first date and do everything for the girl, and by date number 3, they're taking them for granted, and they're already in the restaurant while the girl's out in the parking lot in the car in pouring rain with a huge puddle beside the door, wondering, how am I going to get in there? So this is what the CAD does. The very first time you go into 2D, it'll flip it so that you're looking at the 2-dimensional plane that you're drawing on from a normal view, straight down on it. And when you come back to 3D, it's going to put it on a nice oblique angle on you. And it's just kind of recommending this. From now on, you're on your own. You have to manually reorient the part if you need to look at it from a different angle to do some work. So if you look over at our toolbox on the left, where the directory tree keeps getting booted out of, you can see it says Boss Extrude, and from the sketch plane, yeah, that's what we want. We want this thing to grow from the plane we drew it on. Underneath that, it says Direction 1, and it says Blind. So if you click on blind, you'll see that there's up to vertex, up to surface, offset from surface, up to body, mid-plane. So there's various options of where you can extrude to, like how far you can go. Because we don't have anything else here to refer to, we're going to stick it on blind. So to change the length, we've got a couple of ways we can do it. We can kind of 3D sketch it by grabbing the arrowhead and pulling it. Click, hold, and drag. And we can make it thicker or thinner that way, and we can go on either side of the drawing plane and it's fine. We can even grab the second arrowhead and draw it both ways from the drawing plane that way. But it's kind of rough. It's not an accurate way to do it. So of course we've seen that we can use equations in our dialog boxes where we can put numbers. We've seen that we can use equations. We've seen that we can mix units. So any valid equation will work. And we're going to make this thing out of 3 layers of our 4.7 millimeter plywood. And I'm pretty sure that 4.7 times 3 is 14.1, but I'm not 100% sure. So I'm just going to type in 4.7 times 3. And then I'll click anywhere, and that gives me 14.1, and it adjusts the part to that size. And my nice yellow 3D preview here, the kind of translucent yellow 3D preview. And that looks good, and I'm going to say yes. And I've got my 3D part called Boss Extrude 1. I don't know about you, but when I have a newborn baby, the first thing I want to do is name it. We're making a pretty simple object, but if we're making a more complex object, we don't really want to leave it with these default names. Because if we've got, say, 30, 40, 50 different features in an item, and then we come back to it, say, 3 months down the road, we haven't looked at it, we got busy with something else, we came back to it, and we've got these default names, we're not going to know which is which. Let's rename this thing. So we can right-click on it, and we can go down to Feature Properties, and up in the top will be the name, and we can just type that in. I'm going to call that main block. And I'm going to press OK. Now I can also click on it and then kind of hover there for a second, and it will go over into an editing mode for the name. Or I can click on it once and I can press F2 and it will also go into the editing mode. So there's 3 different ways to get into this thing to edit the name. So we've got our block, we've got the main piece of stuff we're going to carve this part out of. And it's as big as or bigger than the part. So we're going to remove material from here on in to get this part. We're looking at it on an angle. Now we've got a 3D object. We can go play with our cube tool there, the view orientation tool, as it's more properly called. And we can go and we'll hover over a side, and up in the upper right, we'll see our preview of what we're going to see if we click on it, and it'll orient it that way. But if we want to kind of just examine it, there's an even better way, and this is probably one of the most fun tools in the CAD. Everybody loves this one. If you push the mouse wheel down, push it down and hold it like it's a button. So just push it in and hold it, and then move the entire mouse. You can orient the part in 3D space freehand. It'll just kind of roll it all different directions. It takes a while to get used to it and to kind of figure out how it manipulates it. But it's great for examining when you don't need it really accurately positioned. You just want to kind of look and see what's where. It's better to use the roller tool. When you need to accurately position it to do some drawing or get some dimensions or something, then it's best to go with the cube. Well, that seems like a good spot to stop for lesson number 2. So we've now covered all of the common errors that we're going to get. They're going to give us grief and frustrate us and leave us confused. And we've learned how to draw a solid object. It's a pretty long path to a block. But from here on in, we can start to carve away at this and give it shapes and give it features and do all sorts of really fun stuff with it. That's it for lesson 2C. In lesson 2D, we'll start to shape this block.